third. So it is a R1, R2, R3, and both three resistors are connected at the one point. It is a neutral point, we can say N. Similarly, we will transform this network into equivalent delta network. Now we give the name first, second and third one. Similarly 1, 2 and 3, and there is a 3 resistor RA, RB and RC. Now we have to derive the relation between star to delta, but as we have previously done, we know the equation of delta to star transformation. So using that equation we will go forward. So we know the equation from delta to star transformation. We know the 3 equation. First equation is R1 equal to RA RC upon RA plus RB plus RC, equation number 1. Similarly R2 equal to RA RB upon RA plus RB plus RC, equation number 2. And similarly R3 RB RC upon RA plus RB plus RC, equation number 3. Let's see how this 3 equation comes. So first we go for the branch number 1, where we have to find out the R1. So R1 is connected with 1. So similarly in delta network, 1 is connected with RA and RC. The equation is simply we write down that RA into RC. In a denominator, the summation of all 3 resistance. So see, as shown in the equation, first branch is connected with RA and RC. So first equation is RA into RC, RA RB RC. Similarly R2, 2 number is connected with R2. Here 2 number is joining RA and RB. The equation is RA into RB, RA plus RB plus RC. That means in this equation the denominators remain common, the numerator parts will be changed. So simply we got the 3 equation. Now next step is to multiply the equation number 1 and 2, 2 and 3 and 3 and 1. So we multiplying the equation. Now go for the multiplication. So we write down multiply equation 1 into 2, equation 2 into 3 and equation 3 into 1. So first we multiply 1 into 2. On left hand side we get R1 into R2 equal to RA square RB RC, denominator RA plus RB plus RC. Similarly if we multiplying 2 into 3 we get R2 into R3 equal to RB square RA RC. Again denominators remain common, but as we multiplying R1 and R2 the denominators are same. So RA RB RC bracket is multiplied with 2 times, so we get the square of the bracket and give the equation number 4, 5, and then third one is R3 into R1 RC square RA into RB, RA plus RB plus RC square. So it's a 6 number. So in a technique we remember that we have to write down the 3 equation of R1, R2 and R3. Then we multiply 1 into 2, 2 into 3 and 3 into 1. That's why we get the equation 4, 5 and 6. Now we adding all these 3 equations. That means add equation number 4 plus 5 plus 6. We adding this 3 equation. See what happens when we adding these 3 equations. When we adding this 3 equation, we get R1 R2 plus R2 R3 plus R3 R1 equal to, now we adding equation 4, 5 and 6. So we get denominators are common. So in LCM part we take denominator and numerator parts are just added. So numerator becomes RA square RB into RC plus RB square RA into RC plus RC square RA into RB. In denominator RA plus RB plus RC square, because in these 3 equations denominators are common and it is taken as a denominator LCM. So now in the numerator part there is RA, RB, RC in a 3 terms. Then we are taking out the common RA, RB and RC. So in the first term RA is remember, in second term RB and in third term RC. Denominator RA plus RB plus RC bracket square. Now as seen in the equation, upper part and lower part both are the equal, then one time it is cancelled. So remaining equation is become RA RB RC upon RA plus RB plus RC. So it is known as equation number 7. So I am write down the left hand side R1 R2 plus R2 R3 plus R3 R1. So this is one important equation. We derive that R1 R2 plus R2 R3 plus R3 R1 equal to RA RB RC upon RA plus RB plus RC. From equation 3 we modified and we get the value of RA, RB and RC. So in that part we separate out the B and C part. So see, from equation number 7 we just take as a reference equation number 7 here. So see, from equation number 7 I am taking RA as a outside and second part is RB RC upon RA plus RB plus RC, that is in multiplication and equal to R1 R2 plus R2 R3 plus R3 R1. Now remember our previous equation which we have write down equation number 1, 2 and 3. So from equation number 1 RB into RC. So from equation RB into RC is known as R3. So RA from equation number 3 it is R3 equal to R1 R2 plus R2 R3 plus R3 R1. Now R3 in multiplication it goes into division, then we get R1 R2 upon R3 plus R2 because R3 cancel and plus R1, and by arranging this term, we get RA equal to R1 plus R2 plus R1 R2 upon R3. This is the first equation of first branch RA of delta. So see how simple, just we modified the equation number 7. We just take RB into RC into multiplication and we separate out this part and we get R3. R3 goes into the denominator and R3 will be cancel out. So we get R1 R2 upon R3 plus R2 plus R1. So simple equation is arranging R1 plus R2, R1 R2 upon R3. Now similarly we go for the equation of RB. So from equation 7 again, from equation 7 I am taking RB as a outside and remaining part is RA RC upon RA plus RB plus RC equal to R1 R2 R2 R3 plus R3 R1. Now what is A into C? RA into RC is known as R1. So RB and this is R1. So R1 equal to R1 R2 R2 R3 plus R3 R1, and similarly equation of RB becomes R2 plus R2 R3 upon R1 plus R3, because when R1 goes into the denominator, R1 will be cancelled. Here R1 into the denominator and here R1 again cancel. So R3 is as it is, and by arranging the term we get RB equal to R2 plus R3 plus R2 R3 upon R1. It is the second equation of RB. So let's see, from this two equation of RA and RB, what we conclude that R1 plus R2, then here we have multiplication of R1 R2, R2 plus R3, we get the multiplication of 2 and 3. So similarly I write down the equation of RC. So equation of resistor RC, we point out here. Similarly we get RC equal to now R1 plus R3 plus R1 R3 upon R2. We will write down again RC equal to R1 plus R3 R3 upon R2. So it is the equation of RC. So similarly we get these three equation of RA, RB and RC. That is called star to delta transformation. From the value of R1, R2 and R3 we get the value of RA, RB and RC. So it's a simple derivation. We have to just remember three techniques, that first we have to add the equation, first multiply and then we have to add equation. Okay, now we have to go for one example of this sum. So what the equation, see in the PPT, the example is given, convert delta transformation into the star. Delta resistance values are given, we have to convert this delta into the star. That means we get R1, RA, RB and RC. We have to find out R1, R2 and R3. So we know the equation of R1, R2 and R3, then we can simply find out the value. So let's solve out this this sum. So write down the first equation. In example, we have already given that RA equal to 30 ohm, RB equal to 40 ohm and RC equal to 50 ohm. So first equation to find out the value of R1 is RA RC upon RA plus RB plus RC. So simply put the value of RA and RC. RA is 30, RC is 50 ohm upon 30 plus 40 plus 50. So we get R1 equal to 30 into 40 in denominator, 30 plus 40 70 and 70 plus 50 we get 120. Now simply we cancel out that this two term, 30 0 cancel, 3 4s are 12 and sorry here we have 5. Okay, so we get 50 divided by 4, and when we take the division of 50 divided by 4 we get 12.5 ohm. The first resistance is 12.5 ohm. So similarly we can find out the second also. Second is R2 equal to RA RB upon RA plus RB plus RC. Simple, put out the value of A and B, that is 30 into 40. Now take the addition, 30 plus 40 plus 50. It's a very simple, 30 into 40, denominator we get 120, 4 3s are 12 and 3 3s are 10. That means simple we get answer is R2 equal to 10 ohm. Simple, when the values are cut out we get R2 equal to 10 ohm. And similarly we go for the